And thank you everyone for joining today's webinar. We're talking today about Azure Machine Learning. So first, for anyone in the audience who isn't familiar with Thorogood, I'll give us a quick introduction. So we are a specialist business intelligence and analytics consultancy with over 30 years of experience delivering business intelligence and analytics solutions to leading enterprise organizations. The solutions we deliver are still based on our founding principle from 30 years ago, and that is that by always locking onto the business goals and then unleashing the technical and analytics capabilities, we're able to maximize the opportunities from those business objectives. And we maintain this business focus across a range of our delivery areas. So that goes right from training through delivery of solutions into things like initial strategies and roadmaps to the full solution implementation and the wider rollout of any of the solutions that we build. And we do that by not only maintaining solutions, but by empowering individuals and organizations they work for to use the tools that we create. So on to today's topic then, Azure ML. We're going to look at Azure ML right across the data science project lifecycle. So to help you understand how you can use Azure Machine Learning to find valuable business insights and create data-driven decision making, we're going to start by discussing that data science project lifecycle, and then we'll take a look at how Azure ML supports the different parts of that process. To start with, every data science project starts with a business challenge or opportunity and an exploration of how we might use the data to improve the way we work. Once we understand those business goals, then we're going to look at the data that we have available. So looking at what data might help to answer those questions, and is there anywhere else in the organization we want to look for data, or maybe we might even consider gathering or buying in new data sets if that's what's needed. Then within the data we've chosen, we'll run an exploratory data analysis. So we're looking there at what are the variables that are available, which might be drivers for the outcome we're looking at, and are there any variables with correlations or other patterns that give us a first indication of what the data tells us about the business process we're trying to model. Then we get into the data engineering phase, and there we're trying to take the understanding we've developed on the data set and build out the variables and patterns to create features that give us a data structure that supports the modeling step, which we go into next. That modeling phase then is where we look at the various different machine learning algorithms that we have that might give us answers to the business objectives and the business questions that we set out with. And that allows us to experiment with several types of model, and we'll evaluate each of those from a statistical point of view and choose the model that best supports the business goal. The evaluation step then is about reviewing the model not just from a statistical perspective, but also looking at and considering how well it supports delivering on the business objectives. So is that model going to support end users to make better decisions and give us the added value that we set out to achieve through this process? And then finally, once we've got a model that passes those criteria, we want to deploy the model and importantly monitor its performance going forward, checking it continues to make the right predictions and recommend the right decisions even as the data set changes and as the latest data comes in. And so looking across that whole project lifecycle, Azure Machine Learning supports the journey the whole way across, right from the early stages of exploring the data through to modeling and deployment and monitoring. So for today's session, we're going to focus most of our time on how to build models in Azure, and we'll talk a little bit about the deployment as well. The other thing that Azure ML supports is the MLOps approach. So that's a way to make the actual process more robust and automate the steps where appropriate. We've covered that in a separate webcast a couple of weeks ago, so we're going to skip over that bit for today. But if that's something that's of interest, please feel free to reach out, and I'm happy to have a discussion on that topic as well, and we can point you at the webcast on that if that's helpful. So when we're thinking about building machine learning and AI models in Azure, there are a range of different tools that we can use depending on the use case and the user preferences. So things like whether you're looking for a low-code, no-code approach, right through to building deep customization and modeling complex business processes, or even things like pre-built models that deliver high-quality results straight out of the box for standard questions, such as sentiment analysis or recognizing objects and images. So we're going to start by looking at cognitive services, which is some of those pre-built models you can just pick up and use. Then we'll take a look at Azure ML Designer, which gives you that low-code, no-code approach by using a drag-and-drop approach to machine learning. Then we'll look at Azure Machine Learning's automated ML capabilities and how you can use that to help you find the best models far more quickly by letting the computer look through a wide range of the model options. And finally, we'll look at a code-first option, so something like Azure ML Notebooks or Databricks, And we'll show you how you can use those and leverage some of the added Azure ML features, like experiment tracking and the model registry, to ensure that when you're building your custom code, you can get the most robust, repeatable process with the entirely custom machine learning models that you're building out using those languages. So as I said, we're going to start by looking at cognitive services. So to introduce it, cognitive services is a set of pre-packaged machine learning models that Microsoft have built to reduce the setup and the time needed to train the model. So if you think about that while you're setting up, you can choose to run it on a pay-per-use basis, or you can commit to certain consumption per month, and that gets you a bit of a discounted rate. And there's also a free tier that you can use to try it with a fairly small number of requests. But it's a great option to take a look and see how it works. Cognitive services supports a range of use cases. So we've got the examples here on the screen. Some of these are ready in production. There are a few others. You see the ones in the lab. The labs on the right-hand side of the screen that are kind of in testing and they're early stages, but all sorts of kind of standard approaches here from language analysis, text analytics, translation, through to things like computer vision, that you can look at images and figure out what an image is just by looking at it. So I'm going to show you a quick demonstration of what one of these looks like, and this is the custom vision. So I've got it here open in the browser, so you can see this is through a fairly nice to use, easy to use browser interface. What we've done here, very simply, is we've uploaded 5 images of different types. So one of those categories we've got is windsurfing images. So we've got five categorized as windsurfing here. If I click on this, you'll see which those 5 are. Hopefully, it's fairly obvious. And we also then got 5 people here and 5 pictures of cats. And that set of 15 images is enough to train for 3 different categories. And from there, we run the train model, so that takes maybe a couple of minutes to go. But I've already done that ahead of the session. What we're going to do now is test the model and check that it's able to pick up from what we've got. So I've got an unidentified photo here. I don't know if you can see that on the screen in a minute, but as I load it up, you'll see it here. So we've got, hopefully we can all recognize as an image of a cat. And here, you can see the tool is giving us a probability that it fits into each of these 3 categories. And reassuringly, it's predicting 99.9% probability of it being a cat. Now, this is a fairly simplistic model, but what it helps to do is get an idea of what some of the custom cognitive services applications will enable you to do. So something like this, as a computer vision app, here I've got it identifying just some fairly simple images, but you could use it, for example, in a factory to spot defects in objects, or there have been cases of this kind of computer vision being used to spot health and safety issues in the office. Various different approaches that you can use. And the great thing with this is that we trained this method on only 15 images. Microsoft has done a lot of work to get it up to the point where we only need to give it kind of final helping hand, and it's able to pick up from what I've got tagged there. So that's cognitive services. Kind of very brief introduction, but that's the first of the 4 different build methods that we're going to look at today. The next couple fall into the main Azure Machine Learning tool. So before we get into those in more depth, I just want to show you the interface and give you a quick tour of what's available here. So I've got a screenshot on the screen, and I'll talk you through the various different things that you can see in the menu on the left. First off, we have 3 different tools for building models. So there's notebooks, and that's for writing Python and R scripts. There's an automated ML tool and a drag and drop designer. We'll come back and focus on those in just a minute. Next off, we've got data sets, and that's a place to collect organized data sets ready to use in building models. This allows you to track different versions of a data set. So as new data becomes available, you can update the data set. That will store it in Azure Storage, and you can have that hooked to your model so that the model will automatically pick that up and update to ensure it's accurate based on the latest information available. The experiment portion of the tool then provides a way to log all of your ML experiments. So every time you build a model using Designer or Automated ML, the details of the run, be that model metrics, different outputs, images, model logs, and so on, you can save those into this organized experiment store. And also, if you're using R or Python, Azure ML provides a way to log the details from those runs in the same place, so you can keep details of all of your experiments all in one place in that organized store. Pipelines then allow you to create a series of data transformations and machine learning algorithm steps. So they provide a way to put those together and then publish them as RESTful APIs that allow you to connect your ML models with other applications, so things like web applications or front-end visualization tools so that you can provide the machine learning outputs to decision makers in the business. Next, we have the model registry, and this offers, again, a centralized place, this time to actually store the models themselves, and whether that's models provided as a pipeline in the Azure Machine Learning format or a model package to run as a Python script. So there are various different ways to save into that model registry, but the key thing is it's somewhere that we keep all of our models in an organized place. We can tag them for searching later and come back and find our models later on. Endpoints then is where we publish the models to. So whether that's real-time endpoints that interact with other applications to provide results based on user input. So as a user makes selections, it gives them feedback immediately based on the model, or we have pipeline endpoints that will score whole data sets at once and perhaps write the results into a database. You can look at those results in the model later on. The final three here are a set of management functions. So compute allows us to control the Azure virtual machines that run behind all of Azure Machine Learning. So that gives us the flexibility to balance cost and performance so that we're getting results in a timely manner, but at the kind of the cost efficiency that we expect from cloud applications. Data stores is then how we specify connections into things like Azure Blob Storage, file share, data lake storage, several types of database in Azure. And so when you upload a data set into the data sets space, that will store it into one of those Azure stores for you. And then finally, data labeling is another management function that's a great option if you're doing things like labeling images for machine learning. So I showed you there briefly how we do it in cognitive services. There's a fairly similar interface here in Azure Machine Learning, so if you want to build custom models yourself to do that, this still provides you a useful way to tag those images. So you can upload the images into Azure Storage and then have perhaps a set of users even go in and tag those images, and as they start to tag the images, you'd have the machine learning algorithms already start to pick up and make suggestions, and the user can then say, yes, that suggestion is correct, or no, I want to go and manually reclassify that image. So that gives you a tour of what's available in the Azure Machine Learning Studio. What I want to do now is take a bit of a deeper look into a couple of different tools in there. And in just a minute, I'll hand over to Akalya to give you a couple of demos as well. Just to introduce the tool first, Azure Machine Learning Designer is a collaborative drag-and-drop tool that you can use to build, test, and deploy predictive analytics solutions on your data. It also allows you to publish models as web services so that you can easily consume them using custom applications or BI tools such as Excel or Power BI. It has a range of built-in machine learning models that we can simply pull into the drag-and-drop interface, but we can do some final manipulation with built-in ETL tools. And of course, we can extend that with custom code using Python or R. Realistically, you'll get a balance there, depending on how much custom code you're doing. There's obviously the code-first tools, but this is a great option if you want to kind of blend and do most of it by dragging and dropping and then use the R and Python just to extend that last little stretch. I think the best way to see what's possible is going to be go into the tool itself and give you a demo. So I'll hand over to my colleague Akalya to give you a tour of the tool now.
Hi everyone, my name is Akalya. I've been with Thorogood Bangalore for about 6 years now, and in the BI and analytics space for about 13 to 14 years. So we'll now look at the Azure ML Designer, and we'll see a use case to see how we can use Designer to solve our machine learning problems. Okay, so what we'll be doing today is predicting the probability of a credit card defaulter. So as you might know, it causes a major cost for all card issuing companies. And it will be better if the card issuing companies are able to predict that these customers are likely to default so that they can take necessary action. This is where machine learning is going to help us in understanding the percentage of those customers who are likely to default in the following month. So what is the data set that we have? We have the customer information like gender, age, the education level, their past payment behavior, and the latest bill information. Yeah, so now based on this information, we should be able to understand the past behavior of them and accordingly predict what's going to be their behavior in the next month. So let's now look at an example of how we are able to do this using Machine Learning Designer. Let's just get into a quick demo. As Andrew showed you, this is the ML Designer, and the data set that we have is the credit card defaulters data set. every machine learning process will need to split the data into two, one to train the model and the other to test the model. So as you can see here, we are using 70% of the data to train the model and the remaining 30% to test the model. So once you split the data, we train the model using a specific algorithm. Now, there are a variety of algorithms that you can use for this purpose. And in this example, we are using a two-class boosted decision algorithm here. Depending on the use case, the algorithm that we choose will vary. And based on our experience, we should be able to tell us which of the algorithm best suits the particular business case. And once we train the model, we need to be scoring the model based on the trained data set and test that model with the remaining 30% of the data set. So after you score the model, you can evaluate the model to see if this is the best model that we would want to use. So now, what's the output of this whole process? So as part of score model, you would be able to see the various input columns that we provided, and along with this, it would give you a score. So as you can see here, there is code labels and code probabilities, and the default payment next month is the actual defaulters, and the code labels is what has been predicted through this algorithm. So as you can see here, not all the cases are right, like all the probabilities are right. So that's where the code probabilities come into picture. And if you look at the case, like what is the next step based on this information is what we need to be looking at. So what you have is like the credit card companies need to understand what percentage of people are likely to default in the next month. So let's say you look at the top 20% of the people who are likely to default, and based on that, they can change their payment plans or take any other necessary action much earlier in time. And that's how this is going to help you. The next step is evaluate model, and the evaluate model gives you a set of metrics that you need to be aware of in order to arrive at the best model that you want. So the metrics, so there are three different charts here which help you understand whether this is the best suited model, and based on the threshold value that is set, the metrics are going to change, like the accuracy, precision, recall, and different score. And based on this information, you should be able to derive at the best model for a particular use case. Yeah, so these are the various metrics that we saw there. So just a quick look at what these metrics are. So accuracy is going to give you a proportion of the total predictions that are accurate. This is the most important metric that we would be looking for as part of every model. The next is precision and recall. That's a comparison between the positive predictions and that are actually positive, comparing that with the actual positive cases. And the F1 score is an attempt to balance both precision and recall. So that's about using ML designers to design a particular algorithm that we would want for answering some of the business questions that we have. Now let's move on to automated machine learning. So if we have a question like to understand what is the worth of a particular car, how do we go about doing this using machine learning? So what we need to do is understand the features that it has and the various algorithms that we can use for this use case and the hyperparameters that are available for this case. So let's now consider the list of features that we would want to analyze the data on. So it could be mileage, condition, car brand, etc. And there are a variety of algorithms again. So as a first step, let's look at mileage, car brand, and year of make as the features that we would want to consider. And we'll go with gradient boosted algorithm. And these are the parameters that we'll be using for the gradient boosted algorithm. And the automated machine learning is going to analyze this model and tell you the score of this particular model. So we arrive at a result of, say, 30%. Is this sufficient? Maybe not. So we'll have to look at all the other models that are available to us and choose the best one that gives us accurate results. So we iterate the whole process, again, by choosing different features, different algorithms, and the hyperparameters corresponding to those. and now we arrive at a different algorithm which gives us 50% accuracy. Again, we might be able to get another algorithm which would give you a better score. So this is typically going to be an iterative process running through each of the algorithms with its corresponding features and parameters. So we do the iteration multiple times until we arrive at a comfortable score, which is going to help us answer all those questions. So what if there is a way to automate all of this? And that's exactly what automated machine learning does. So you will have to provide the list of data points for the automated machine learning. You define your goals and apply any constraints that you might have. And what will machine learning do is test multiple models in parallel, and it would give you the most optimized model, which has the highest score. This way, we have saved a lot of time that otherwise an analyst or a data scientist would have to do to run all of those models and then come up with an optimized model. So now, all the time that the analyst would normally spend in arriving at a model can now be spent in understanding the inner workings of the machine learning by analyzing each of the features that each model has considered. So feature importance is going to be really useful for us to determine whether to go with the model, which model to go with. So as you can see here, it shows that the 95% model has taken mileage as the utmost importance for it to calculate the score. And the next best model, which is the 70% model, has taken condition as the important feature. So based on our particular use case, we might want to use a different model. In our experience, what we have seen is most of the times we would like to go with the model that automated ML has predicted, but there are cases where we want to understand the features and accordingly change the model. So how do you understand the features? Automated machine learning provides us an explainability for every iteration that it runs. And although theoretically it is possible to enable the explainability for all the models, but again, what we have seen is you wouldn't want to go through all of the models and to derive the optimized model. We generally look at top 3 to 5 models and then decide on which is best for this particular use case. So we'll just understand how we do this in automated ML. Okay, so it's pretty simple. In automated ML, it has just 3 steps. You will have to define the data set that you want to use for the particular business case, and you configure the run, and then you look at the task type and configure the settings. Now, for this case, I've taken the NPG data from the Azure portal, and we'll create a new experiment. And the main important point to note is the target column. What are we trying to predict? So that's when MPG is the target column that we have specified, and based on this is when the prediction is going to be. Next, we configure the run. So every machine learning problem falls into one of the 3 categories: classification, regression, and time series forecasting. Classification is going to give you categorical output, so something that we saw earlier, whether a particular customer is going to default or not. It's going to give you yes and no values. That is a classification example. And for regression, it's going to give you continuous numeric values, like predicting the price of a particular car in this example. The third section is time series forecasting. Mostly based on the historical trends of sales, we'll be able to forecast what is the sales going to be for the next month or next quarter, and that's where you use time series forecasting. So there are certain configurations that we'll have to set as part of the automated machine learning run, and the primary metric is of utmost importance. This is when it decides which is the best model. So here we have selected normalized root mean squared error, and there are various other metrics. And since this is a regression problem, the metrics is also different when compared to a classification problem. So based on the metric that we choose and other configurations like concurrency, etc., we could define, and the featureization as well. So it lets you provide options for all the columns that is available as part of the data set. You would leave it to the default as well for the automated machine learning to decide. So we'll just quickly go through how this is being done and what's the output of automated machine learning. So we've already run this. Once you do the list of steps that I had shown in the presentation, and we run the machine learning model, it takes a few hours to run, and then it provides the details in the manner that I'm showing here. So it shows you the best model summary, and as you can see, Stack Ensemble is the best model that it has come up with. And if you want to know the list of models that it has tried out, you can go to the models pane. And as you can see, there are a variety of models that it has tried. And it usually starts with basic models like decision tree, gradient boosting, and then it goes into more advanced machine learning algorithms. And Stack Ensemble combines all these models so that it ran as part of the previous iteration and finds an optimal combination that it will be able to use for this particular business case. I also explained about the model explainability that is available. So by default, it provides the explainability feature for the best model only. However, there's an option for you to look at the explainability for the rest of the models that it has evaluated. So by clicking on the particular model, you could go to Explain Model and see what are the features that it has considered as part of that particular model. So if you look at the view explanation, it's going to tell you that these are the top end features that it has considered for the first model. And for the second model, you can see that the list of features that it has considered could be different. Like in certain cases, brand is considered as the top third factor. And in the previous example, brand wasn't in the top 5. So based on this information and the use case that we would want to do, we generally look at these explanations and arrive at what's the best model that we would want to use. That's about automated ML. I now hand over to Andrew back to take you through Databricks.
Thanks, Akalya. So the final build tool that we'll look at is Azure Databricks. And so there are a whole range of reasons why Databricks is a fantastic tool for building machine learning models using Python or R code. And we've got other webinars on Databricks specifically, so I'm not going to go too deep into the detail on that. But if you want to get more detail, feel free to look at the other webinars, or feel free to reach out to me if you want more detail on that, and we can have a further discussion on Databricks and why that's a great tool if you want to do the kind of code-based machine learning model building. What I do want to touch on, though, is the way you can combine Databricks with the model tracking in Azure ML to get all of your model tracking centralized and deploy all of your models in one place. So in the same place that Akalya showed just a minute ago, the tracking from the automated machine learning, you can get your own model building to track into there as well by utilizing some of the Azure ML SDKs in Python or in R. And those SDKs add specific functions to log details into the experiment log. So using a single line of code, you can save in model metrics or a table of values, or even up to something like a diagnostic plot that shows visually how well the model is performing. And then there's another set of functions that lets you save the model into the model registry and publish it using Azure Machine Learning into some of the Azure Compute resources. So what all of that means is that you can take advantage of the massive scalability of the Databricks platform for building your machine learning models and training them, and then combine that with the fantastic capabilities in Azure Machine Learning for consistent tracking, deployment, and monitoring the models going forward, regardless of the platform that you've built them in. So now that we've talked about how to build a model, the next thing we're going to talk through very briefly is how to deploy a model using Azure ML. So the model deployment workflow involves several steps. I'll take a look at these in a little bit more detail, but just at a high level first. The first thing we'll do is register the model. and then we'll prepare to deploy by getting a few different files together. Then we'll actually deploy it to the compute target, and then finally we'll test and consume the deployed model and web service. So registering the model, what we mean by that is loading it into that model registry that we talked about. And with that registered model, we can add tags so that we can enable us searching for the model later. We can have multiple files that make up the model, and then we can use those files later on to deploy the model as well. And so when we actually go to deploy, that means that all the files are coming from one place, one organized central model repository. And we've got a good record of exactly what's been published at the various different stages in the cycle. When it comes to the preparation steps that we need to carry out, there are a couple of files that we need to provide alongside the actual kind of stored model in the file. And so the first of those is an entry script. And by an entry script, we mean the set of instructions, typically in Python code, on how to take the input data, so that's the input variables that come into the model that are provided to the deployed model, and how we use those input variables alongside the model to produce and format the outputs that we want to return. So be that an output prediction, a predicted class, or even a set of class probabilities. The second file that we need is a dependencies file. Take the case of a Python model, we might need some different Python libraries that are needed to run alongside that to make the prediction. So it's worth noting if you're using either Azure ML Designer or Automated ML, both the entry script and the dependencies files are provided for you alongside the model files that it outputs. So it outputs all of those straight into the model registry, and all you have to do is deploy it. If you're building up your custom model using Python, then there are these few steps to go through to make sure that you have all of the things that you need alongside the model file itself. Once we've got to that stage, whichever of the different build methods we've used, whether we've built up our custom system or whether we've used one of the Azure tools to build it straight in, we can deploy from the model registry into a number of different targets that are available. So for small-scale testing and debugging, we can deploy to a local web service, or use an Azure ML compute instance to deploy a web service. For deploying more robustly, we have a couple of different options, either Azure Container Instances or Azure Kubernetes Service, also known as AKS. And since the Azure Kubernetes Service gives you more control over scaling and high performance, typically that's the option that we'd use in production. And then finally, we're ready to consume the web service, which is provided as a RESTful API. And that comes with a level of security, either using key-based or token-based authentication. So like you'd expect from all of the Azure cloud services, it's got the security options built into it as well. And if you need something more specific, then you can combine the Azure ML web service with some of the other Azure services to give you very complex security models that will match up with your organizational policies. The last thing I want to note about deployment specifically is that you can update a deployed model so that you can either update the model itself or update the entry script or the dependencies file. And the updated model is then added with a new version flag. So when you've got a downstream application that's using it, you can either specify which version to use, or you can have it pick up the latest version. And that way, the model registry will keep a copy of the latest version of the file, and you then have the most up-to-date version deployed to web servers as well. So just to finish up, I want to look at a topic briefly that goes beyond just building the ML models in Azure and think about some of the considerations for sharing models with business users. So the first thing to think about is how users are going to interact with the model. And here we have two main approaches. So we've got either batch or real-time. When we talk about a batch scoring approach, that means we make a whole load of predictions at once and present the model outputs alongside the data. So for example, if we want to use a machine learning model to decide the next marketing campaign we should use to target each customer, we can run that over our entire contact database and save the results for each customer into the database for the marketing team to reference later on. In real-time scoring, we allow users to interact with the model more directly by providing a specific set of inputs each time. And maybe in that case, we've got the marketing team wanting to enter some details of a proposed new marketing campaign, for example, and then we can use a machine learning model to estimate then and there how much return on investment we might see from that campaign, and allow the marketing team to use that model in their decision-making in that way. So here is one example of a dashboard where we use batch scoring, and here that's allowed us to present the series of predictions and recommendations all at once. And also, because it's stored in the same place in the database as the source data, it's really easy for us to provide the results in context. So users see not just the outputs of the model, but they also can understand that in the context of the wider picture that influences the exact decision that they're going to be taking so they can be guided by both the model and an understanding of what's happened before. And then an example of a real-time web application that might be used to decide how to price a new insurance policy in this case. Here the user entering details of the new customer. When they press go, that sends a request to the model, and the web application gets back the estimated likelihood of potential size of the claims. And again, in this case, we'll provide some context just here, rather than coming from individual cases, coming from the data set that we use to train the model in the first place. So we're putting a new case in the context of what that looked like compared to, again, what we've seen in the past. Beyond thinking about the presentation then, we need to evaluate the model from a business perspective. So often when we think about evaluating machine learning models, the focus is on statistical accuracy, but it's also important to think beyond that and look at how users are going to use the model. And to do that, we want to have experienced business users review the model alongside statisticians to look at whether the recommended decisions make sense, to make sure that they seem reasonable. From there, you need to check that using the model is going to deliver the business value that you set out to achieve. And finally, you need to make sure that users are confident implementing the advised actions as part of that. And if there are any additional context that's needed, then you can work with the users to decide how to display that alongside the machine learning model outputs to make sure that they're going to be confident using the decisions that they're recommended by the model so that they're delivering business value. So that gives you a really brief introduction really into all of what's available in Azure Machine Learning. So that brings us to the end of today's content. If you're interested in finding out more detail on any of what we talked about, please don't hesitate to get in touch. There are a couple of ways that we can help you to get started. First off, if you've got a few users in your organization who are interested in this kind of topic, we've got a 2-day workshop that will introduce Azure ML in more detail, including some hands-on exercises and an opportunity to build on your own use cases with our experts on hand to help as well. And we find that's been a really helpful session to do with a couple of customers. So that brings us to the end of today's webcast. Thank you for attending, and I'll leave our contact details on the screen for a minute if you want to get in touch about any of what we discussed today. Otherwise, thank you, and we hope to see you again at some of our other webcasts.